Oh, hey friends, this works. It's been a long time since I've been on, so I'm just kind of surprised that I managed to make it all work. Unless you're all going to come back now and tell me you can't hear a word I'm saying. Let's see. Let's hope it all works. Okay, anyway, I'll pretend that it's working. I'll just keep on babbling here. So, the story is I have been overloaded all this semester. I had to teach an extra course. And so I've been struggling a little bit and haven't had a lot of free time, but spring break has sprung. So I'm able to do various things again and relax and have a good time. Okay, I got word from the comments that it's working. It's like magic. I was really afraid I would forget something really critical, and there was no way it was all going to work. Anyway, here we are. I'm on spring break. Which just means my teaching duties have been suspended for a little while. I still have some grading to do, just a bit. I think I can handle it. And then I'm just doing research every day, going and working with the spiders and all that kind of cool stuff. So it gives me a little bit of slack, which I appreciate for a change. I'm also planning on doing things like getting enough sleep every night. Yeah, I'm also thinking, I've seen myself here. I think I can start combing my beard again. I'm looking all Old Testament here. Uh, that's because I wear a mask all day long, and it turns out that really curls and frazzles your beard. So uh, I can stop doing that for a while as well. Okay, so I actually planned something to talk about. I have a theme I'm going to discuss today. In addition to just opening it up and letting people ask questions, I have a really simple theme to talk about, and that is the ignorance and arrogance of science denialists. I have been kind of peeved lately because of the foolishness of what so many people are saying. Ah. Yeah. So what kinds of things do I want to talk about? First of all, I'm going to go over that paper I discussed on my blog earlier this week, because that was infuriating. Just reading that frazzled me because it's typical creationist nonsense. They just don't understand what they are writing about. And yeah, so shall we just plunge into it? Let's talk about this paper. First, I have to find it. Let's see, I'm sharing the screen, and that's gonna go right there. All right, there we are. There I am. Oh, I notice my comments will vanish when I do this. Let me do a little tinkering here. Just so I can see what people are saying as I'm talking, because you're part of this game too. Okay. So this is this paper I took apart earlier this week. It's published in Biocomplexity. If you don't know it already, Biocomplexity is the internal house pseudo magazine of the Discovery Institute. It's garbage. It really is. They don't publish very much stuff either. I had a comment from someone that Biocomplexity has 31 editors, and they publish 2 or 3 papers a year, which is kind of impressive. Yeah, that's pretty low productivity. And what it tells me is that if you're an editor of Biocomplexity, you're there mainly to have your name on the masthead and all the glory that accrues from that, but you're not really actually doing any scientific work. You're just rubber stamping things as they come through. Notice also that the editor for this paper is Douglas Axe. Yeah, another creationist who does sort of crappy molecular biology. So he's really not qualified to talk about this paper, which is entirely, completely about embryology. I know that's kind of like that's one of the things I do. And so here they've thrown this up there that's it's like red meat to me. So uh, this paper, as you can tell from the abstract, is he's pointing out that the embryonic development of vertebrates from different classes pass through a phylotypic stage, which is true, they do. And they say, like he says, they do look similar, but there's differences, significant differences, even at the phylotypic stage that he's not bringing up, because he wants to emphasize something else, which is early in development. If you go back to like gastrulation, it occurs differently in different vertebrates. And he's presenting this as, number one, something novel, as something that, wow, we never thought about before. And two, as something that actively undermines evolutionary theory, which it doesn't. As I said, we've seen this many, many times before. Okay, what's the content of the paper? I'm just giving you a blast from a couple of pages of the paper so you can sort of get an idea of the content, uh, which is very familiar. These are just textbook diagrams. This is stuff that gets published in all of the developmental biology textbooks. It's really familiar stuff. So there's nothing new here, okay? And let's be clear about that. This is absolutely old stuff, not at all exciting. But he's pointing out that, yeah, you look at zebrafish there at the top left, and they've got an epiblast. That's a layer of cells on top of the yolky part of the egg. And during gastrulation, the epiblast has to move and migrate under to form the deeper tissues of the embryo. And down below that, there's a frog. This is probably the canonical vertebrate for studying this. It's been studied for, oh man, going on a century now, looking at frog development. And there it's different because instead of a thin rind of an epiblast, as you know, a cellular layer, frogs have somewhat yolky eggs and cleavage divisions go all the way through them. So all of this, you know, this green and this yellow and this blue stuff in the frog, that's all cellular. So you don't have a distinct separate yolk layer in this. Anyway, they do something that looks superficially different, where again, we got gastrulation, we got involution, that's just the folding in of the layers to form the deeper tissues. And yeah, compare a zebrafish and a frog, and they look pretty different. A lot of the processes are very similar, but yeah, they look definitely different. And then over here on the right, we've got a turtle embryo and we got a chick embryo, and they are different yet again. They have gigantic yolk, much bigger, relatively speaking, than zebrafish yolk, and definitely bigger than anything that frogs have. And what they have to do is they separate out a thin layer, kind of like the epiblast of zebrafish, that's floating above the yolk, and there's a space underneath it. But then you have ingression, you have involution, things rolling under, and you also have some cases where there's delamination, where if we looked at a chick, what you'd see is that instead of this sheet remaining continuous and part of it bending and folding under, you've got cells actively delaminating, that is separating from the epithelium and migrating as a mesenchyme, that is a loose aggregation of mesodermal cells into the interior. Gosh, it's all different. And we've been saying this all along. This is exactly as you would find in a standard developmental biology textbook. So this isn't interesting. I mean, it's interesting in a generic sense, but you're better off getting this information from a developmental biology class than from a creationist paper, which is going to distort it. Also, this difference, the way different gastrulas occur, that different classes of organisms have different patterns of gastrulation movement, has been pointed out long, long ago. And this just means I've got an opportunity to mention Bill Ballard. I knew Bill Ballard many years ago. He's a well-known embryologist who studied all kinds of development in all kinds of different organisms. He contributed to the zebrafish staging series, so his name is on that paper that every zebrafish biologist is going to have to read at some point or another. So he's fairly well known there. But in the 1970s, this is from a 1976 paper, he was howling in the wilderness and telling everyone, no, gastrulas are all different. You look at different species and you see these amazing differences between them. You can't pretend that the earliest stages of development are all held in common between all organisms. This is an important point. And he said it over and over again. And Bill Ballard was also the kind of guy who did not go quietly into the night. He was all kinds of ferocious about this stuff. He's spectacularly opinionated, and I really enjoyed meeting him and talking to him many years ago. He died in 1998. Sorry, you don't get to meet him now, but yeah, he was one of the old school embryologists who contributed a lot and was a bit of an iconoclast, and said, no, you gotta recognize that there's differences early in development. From this paper, for instance, he says the plain fact is that evolutionary divergence has taken place at every stage in the life history, the earliest no less than the latest. So he's pointing out that thinking that everything is just smoothly diverging in different embryos is not true, that there's all kinds of changes that have occurred in all kinds of organisms. For example, in us mammals, we have a placenta. It's practically the first division or decision that the embryo makes is to have its daughter cells separate into either a placenta or the embryo proper. And that's unique to mammals. It's not found in reptiles. It's not found in birds. It's not found in frogs. So we know that there's early things that occur very differently. Now, Ballard was writing in 1976, so I'll point out the last sentence here is he's making the point that the genetic, physiological, and cell behavioral processes going on are the same in time and nature. We can't assume that because it hasn't been demonstrated in 1976. It has been demonstrated since. So Ballard is making a reasonable conclusion from the available data. Gotta appreciate that. And he's saying, no, you haven't shown it yet. You haven't shown that there's molecular similarities because they hadn't done that work yet. It's interesting timing because Evo Devo is going to appear on the scene in the 1980s. And that's when we start exposing all the molecular foundations of these differences and characterizing all that stuff. So again, that Swift paper is not creative, never novel. It's saying the same things that Bill Ballard was pointing out in the 1970s, that, yeah, that different species have different early stages of development. And Ballard was saying, yeah, we got to do the stuff to figure this out. You can't just to simply assume, you have to do the experiments. And yeah, they're going to do them shortly after this. Okay, if we read the Swift paper, he says some of the same things. So he says, however, in the light of what we know about how development occurs, it is clear that an exclusively morphology-based rationale is totally inadequate. Bill Ballard would have said the same thing, okay? And Swift then says, we can no longer regard embryonic development as a black box. We haven't, not for decades. Yeah, we've been digging deep into the genetic and molecular basis of development early on. But he says, but must take account of the genetic and molecular mechanisms that shape morphology. How generous of him, how pious to bring this up, which he will not discuss in his paper. That's one of the annoying things about this paper is he says, yeah, you got to take into account genetic and molecular mechanisms, but does he? No, he doesn't. Here's the one nod he makes towards that. This is where Swift has one figure, this figure right here, where he's illustrating the epithelial to mesenchymal transition. Say more about that in a minute. But anyway, it's a well-studied process that goes on in development and lots of other phenomena. And we know the molecules involved. These have been thoroughly dissected. We've taken these apart. And Swift says, okay, this is sometimes referred to as deep homology. And of course, is also seen as evidence of common ancestry because it is evidence of common ancestry. The similarity of embryos at the phylotypic stage is evidence for common ancestry. It's not proof, but nothing in biology is proof. So we got this phenomenon that we have to explain. And here's another phenomenon that's related. That's saying, if you look at these early fundamental processes, you find these molecules involved. And, when I first saw this figure, what is he talking about? There's Wnt and frizzled and delta and notch. I've known about these for a long time, since the 1980s, okay? And what these are common molecules that are involved in these early processes. And the curious thing about these is that they are not intrinsically vertebrate molecules. Those are all found in Drosophila. That's where they were first discovered, is in Drosophila. So these are insect genes, and they're also being expressed in vertebrates. And they're doing similar sorts of things in all these different kinds of organisms. Yet he wants to pretend this is not evidence of common ancestry. It's just really weird. And his excuse is that even just rewiring genetic systems would at the very least require constructive and coordinated generation and or modification of regulatory sequences, which happens in evolution. So this is just dead noise that he's making here. And the EMT, the epithelial to mesenchymal transition, is a really interesting phenomenon. It's been well studied because, in part, it's involved in cancers and how cancers can spread, how they can metastasize. And this diagram just illustrates that you go from an epithelium, which is an array of cells all in a layer, all linked together, and then they separate out from the layer and they go migratory and they crawl off into other places. That's the mesenchymal stage. And when you look at these and you ask, what do they do? There's a list at the top there that's important. Embryo development, all kinds of embryonic development depends on this. They're important in wound healing. So yeah, you do this all the time. If you cut yourself and you get tissue damage and you get an open wound in the skin, how does that wound fill in? Well, it's the EMT. That cells on the edge of the wound just detach from the epithelium and migrate in and proliferate and fill in the space. So it's kind of important. And also tragically, it's involved in cancer metastasis. This is what cancer cells do when they leave a solid tumor and migrate off into other regions of the body. So this is all really fundamental stuff. It's common to all animals. It's there in all of us. So why is he arguing as if this is somehow evidence against common ancestry? Because it sure isn't. It's pretty good stuff. Okay. So that's what I want to say about that. Yeah, go read my article on my blog about this. I'll include a link down below so you can find it pretty easily. But yeah, this is all obvious stuff. And it is so pathetically shallow of this Swift joker to just sort of scan through the developmental biology textbooks and steal a bunch of diagrams from them and then announce these disprove evolutionary theory. Because all the people that are writing those developmental biology textbooks are all perfectly copacetic with evolutionary theory. They don't see this as at all contradictory to the whole idea. Okay, let's just take a quick look at the comments over here. Pandas. What are you guys doing talking about pandas? Anyway, they're talking about pandas over there. I don't know. Let's see. Okay. Cryptonic mentions she questions all animals. Do all animals go through this? Yeah, even sponges. Sponges do this too. They have to. You know, if you shred a sponge and pull it apart, and it reconstitutes itself, it regrows. The way it does that is it's going to have cells that proliferate, that detach and proliferate and fill in the gap and build that developmental structure. So yeah, it's really common. Another question, plants and fungi versus animals. Do plants and fungi do anything like this? Not exactly. Plants have another constraint in that all of their cells have a cell wall, and that makes them incapable of the kinds of migration we're seeing in these mesenchymal cells. So they don't have a true mesenchyme. But a plant biologist would probably come up with some examples of plant cells that disaggregate and form this sort of thing. You know, but even there, I don't know. I'm not a plant person. I'd have to dig deeper to figure that out. So I will check my developmental biology textbooks. I got lots of them, you know, so I'll take a look and see if they have anything to weigh in on that particular matter. Let's see, what about fungi? I don't know about fungi either. Yeah, fungi exhibit some other interesting, you know, like thinking slime molds. Slime molds exhibit this kind of mesenchymal behavior, you could say. So they can loosely aggregate, they can disaggregate and aggregate. So there's stuff going on. You guys are asking difficult questions. Don't you realize I'm a zoologist type? I mainly know about animals, and everything else I learn about plants and fungi and protists and all that kind of stuff. That's all just a stunning revelation to my brain. Okay, so let me move on. This was a paper by a creationist, and we already know creationists are worthless. But this happens in other fields too, where know-nothings come along and they announce, oh, did you know? They cite a fact that everyone already knew, and they say, but they've been keeping it from us. They've been hiding the truth of whatever. And here I am to bring it to you. Aren't I smart? And this observation completely discredits evolutionary theory or vaccines, or in this case, climate change. So I want to talk a little bit about somebody doing. Oh, another question. Have I ever heard of the Quinling brown panda? That's a subspecies of the giant panda. No, I have not. You're trying to distract me and drag me off of the topic I'm going to discuss, which is climate change. Complete shift. But I have the power. I can do that. I can change everything around. Okay. So what I'm going to talk about is there's this bozo I've actually done a video on before named Greg Braden. And Braden is a weird case. He often comes out and makes these absurd declarations. In this case, he's going to make an absurd declaration about carbon dioxide and climate change. And people just listen to him and accept it when they shouldn't, because I'm sorry, Greg Braden is an absolute, utter, incompetent idiot. So let's see if this works. I'm gonna play some clips from him. I hope the sound and everything comes through. It should. Let's see. So these two bozos.
I'm seeing how universal the demonization of carbon dioxide has become on the global stage. And I'm concerned because of what it does to us socially, for one thing, but also humans tend to go to extremes. Yeah. And when the media harps upon the dangers and demonizes carbon in general and carbon dioxide specifically, the extreme is that all carbon dioxide is bad. And if we were to reduce the carbon dioxide on our planet the way that our officials would like for us to, it literally is a death pact for our planet. Now we can.
Okay, there's so much he threw out there. So we're demonizing carbon dioxide. We're saying it's bad for you. And he's worried that this is going to lead to extremes, that this will get extremists motivated to say absurd things about how dangerous CO2 is. And then he goes on and says, but if we do anything about CO2, that is a death pact for the planet. I know. That's kind of an extremist position to take. Oh yes, I see our commenters commenting on his hair. He's got really strange hair. Yeah, I know. It's a very affected appearance. So first of all, carbon dioxide is a metabolic poison. It's for humans, for animals. It's something that we try very hard to get rid of, that our cells produce this as a consequence of metabolic activity, and we excrete it into the bloodstream and then exhale it out through our lungs. It's not good for you, okay? An excess is not good for you. You could make an argument that we do need a little bit, because the way we regulate our respiration is by monitoring CO2 levels. So we're just looking not at oxygen, but at CO2 levels. And as they start to climb up, then we figure we got to breathe a little faster to counter that. So too much CO2 and you'll die. Yes, correct. That's from the comments. It's not good. And then furthermore, CO2 is a greenhouse gas. So we got to worry that an excess of this greenhouse gas is going to lead to all kinds of problems. It's causing the warming of the planet. And well, he's going to deal with this next. Yeah, he's gonna explain to us that no, CO2 in the atmosphere is just fine. We shouldn't be worrying about it. And you might be wondering how he's going to do that. And he's going to do like Swift did, and he's going to steal stuff from the scientific literature, present it as something novel and exciting and revolutionary, and as evidence that, no, CO2 is just fine. So let's take a look at that.
So the idea that that carbon dioxide is a poison.
Yeah. Wait. Okay, come back. I gotta address that. So yeah, CO2 is a poison. Just like oxygen can be a poison, just like water can be a poison. It's all about the dosage that makes the difference. So you can't just wave that away.
So the idea that that carbon dioxide is a poison is a false narrative to begin with. We are carbon-based beings.
Of course.
We are. And by demonizing the carbon dioxide and carbon life, we're actually demonizing ourselves. And I think this even speaks, John, to a larger agenda that we've talked about, the transhuman agenda, where we've been conditioned to
What a
believe that
transition.
we are
Okay.
flawed as human beings and that we need to correct those flaws through technology, replacing our carbonness with polymers and synthetics in terms of skin and organs and tissues. So it's all part of a bigger picture. But what I'd like to do, John, can I, just for a moment, can I share the screen?
Yeah, sure. Sure you can.
Okay, before he does that, let me just mention one thing. There is no general goal to replace the carbon in our tissues with polymers. Well, the carbon that we have in our tissues is polymeric, but this transhuman agenda is just absurd. That's not the concern here. It shouldn't be the concern. Also, we are imperfect. I can say this having just turned 66, and I can see all the problems with aging that are going on. And these two jokers ought to be aware of it too, that, yeah, we inevitably will age. And one of the things we often need to do is replace tissues in order to prolong our lives and to make our lives more comfortable. Yeah, lots of people when they reach a certain age have to have hip replacements. What does he want us to do about that? We got titanium steel hip replacements, and he's going to be unhappy with that because it's not carbon. This is ridiculous. He's essentially trying to appeal to the purity of our human existence, and no, there's no such thing. Okay, so he's about to demonstrate the fallacy of thinking of carbon dioxide as bad for the planet.
And we've never done this. It's not PowerPoint. I'm just going to bring up an image here. Let me see if it allows me to do this.
That's the Ark of the Covenant.
And
What's he doing here?
This.
Okay.
Are you seeing anything on your screen?
Yeah, I can see it.
All right, good. So what this is, I'm going to move this around a little bit. It's something you don't see very often.
Yes, you do.
Carbon dioxide levels in geologic history. And what you're seeing on the far right is today. Now, our levels, are they higher than they have been in the last 100 years? Yes, they are. We're being led to believe that they have never been higher, that Earth is going to be destroyed if they are any higher, and we're being led to believe that these are driving temperatures higher than they've ever been, both of which are not true.
Okay, did you all catch the folly of what he is saying? First of all, it's a flat out lie that the climatologists and other people who study the Earth are claiming that the levels of CO2 have never been higher. No, we know that they've been higher. That's what this graph is showing, that we know they've been significantly higher in the past. So that's false. He also says, let's see, what does he also say here? Yeah, he says we've been led to believe it's never been higher. Of course it has. And he says this graph is demonstrating it because you can look and you can see it's been higher in the past. And we haven't been shown this apparently. I would just, if I were there in person with Greg Braden, I would ask him, where did you get this graph then? Because it wasn't assembled by some climate change denier. This is the scientific data. When I've never taken a geology course, but I've studied paleontology and I've looked through the texts and I've read lots of books on the ancient past, things in the Permian, Triassic, Jurassic, Cretaceous, etc. And they all talk about this. They all show that not only was CO2 higher, but we also had all these variations in oxygen levels. This is well documented stuff. And it's done by the scientists that he's claiming would never show us this data. Okay, this is just such a lie out of this person. So I saw this and I recognized, no, this looks vaguely familiar. I'm sure I've seen it somewhere else. And it wasn't in the climate change denier literature. Where it was when I finally dug it up was, here's the source. It's from a site called Skeptical Science. These are people who debunk the nonsense that these climate change deniers throw out. And look what it says up there at the top. They're saying a little bit that there's a balance, that it's governed by removal of CO2 by weathering of rocks. It can be outpaced by abrupt greenhouse gas releases, like we see at the end of the Permian mass extinction, or removals that produce the snowball Earth scenarios. This is what they're describing. This is what the scientists are saying has happened in the past. And they're mentioning all these various variations in the concentration of CO2. And the thing is, this is published all over the place. Even for a non-geologist like me, I am totally familiar with this. I've seen it so many times. And here at the end, they explain where it came from. The data from Foster et al., Nature Communications, 2017, the late Paleozoic Ice Age per Rowland et al., and that's EPSL 2019. They're giving the sources, unlike Greg Braden, and you can go check on this stuff. There's also a tab where you can see it broken down in more detail in here. So they're not afraid of telling you the source. They're not afraid of showing you all this data. It's Greg Braden who's being dishonest and presenting this as something unusual. Also, here's another thing from the science. This is on the same page. And what the science says is that climate and CO2 levels have always varied together. During past ice ages, CO2 levels were low, and during warm periods, CO2 was higher. Yeah, because they're going to deny that correlation. That if you actually look at the concentration of CO2 and you look at the temperatures of the planet, there's all these correlations that it lines up very nicely. So, for example, they don't, first of all, they don't predict that the Earth is going to die. They don't predict the end of the planet. What they're saying is that if you look in the past, if you use the record of gas exchange in the planet, you see that 56 to 34 million years ago, the planet was about 10 degrees centigrade hotter than it is now. Whoa. That's hot. So yeah, it was really hot, and there was a CO2 level of 1,500 parts per million. This was a pretty dramatic difference. Braden and this Peters guy aren't going to talk about that. They just gloss over that and say, okay, it was really high in the Cretaceous. CO2 was really high in the Cretaceous, and the planet was thriving and green and warm. And that's true. But would it be comfortable for us mammals, for us human beings? Maybe not. You also got to figure, if it's so warm that the ice sheets melt, then sea level is going to rise. How are you going to deal with that? These are dramatic changes that we have to worry about. Okay, but let me just show you a little bit more of what they go on to say. This is also really annoying. Okay, so Braden is going to continue.
Have been on committees as recently as this spring of 2022, with young people who are doing exactly what you're saying. They've been conditioned to simply recite the data. They don't even question where the data comes from. And so when I show them a chart like this, their question, it blows their mind. They're saying, how come we've never seen this before? And where did this come from? And why didn't we see this when we were in school? And these are some young people in school. Some of them are young people. When I say young, I'm talking about 30s, maybe 40s, who are working with the UN. And what they're saying is, how come this isn't what the UN climate panel is telling us?
Okay. He claims he has talked to young people who can be 30 or 40 years old, I guess. And he says, they have never heard of this before. And I'm going to call bullshit on that. I'm at a university. We have an environmental sciences program. We teach geosciences. We teach planetary atmospheric conditions, all the stuff that he is pretending are surprises. If you talk to some of the students at my university, real young students who are maybe 20 years old, who've taken a few courses in this subject here, they would all look at you aghast and say, but yeah, we knew that. We got an exam on that last week or whatever, that this is routine stuff. And so Braden has to be lying when he says that stuff. Either that, or he's hanging out with really ignorant people who pretend to have knowledge, who pretend to be experienced in geology and geochemistry and things like that. Because no, that's just absurd. You will not find that. Okay. So how do we deal with these people? What are their qualifications, you might ask? And so I looked it up. I looked up to see, okay, Greg Braden says at times that he is a geologist. I have no idea what this Peterson. He seems to be sort of the Ed McMahon to Johnny Carson over here, just agreeing with everything he says and not adding much to the conversation. But they consider themselves these experts in what? Look at the titles they give themselves. John L. Peterson is a futurist. What is that? How do you get a degree in that? How do you do research in that particular field? And Braden's even worse. He calls himself a visionary. Yeah. Okay, he's a visionary. That again means absolutely nothing. Yeah, these are pseudo qualifications. These are guys making up titles for themselves to seem important and informed, and they're not. They're terrible people. So I went on Greg Braden's website to look up his qualifications, and here they are. Here's his career highlights. And look at this. Okay, he's about the same age I am. Yeah, he's maybe a little older, but not much. So here he's gone to community college. He studied marine geology and marine biology at the Florida Institute of Technology. He went to Colorado in 78, 79 and studied geology, got a Bachelor of Science in 1982. Okay, and he does have a bachelor's degree in geology. So he's not lying when he says he was a geologist, but honestly, an undergraduate degree in geology is a good start, but it doesn't make you a qualified geologist. And then he got jobs after he graduated, he gets jobs doing computer stuff. So he's working for the oil companies, working for aerospace companies. He's doing all this computer stuff. He's not doing geology. He's really left geology behind. He works for Cisco. Okay. Those are good technical jobs, but they have absolutely nothing to do with geology or the history of the atmosphere or anything relevant to what he's talking about here. So he left these technical fields to write and teach full time in 1991. Yeah, that was 32 years ago. So he left everything technical behind 32 years ago. And you might say, well, he could be one of these polymaths. He could be self-taught. He could be very well informed about geology. But no, he's not, because here's what he did after he left those fields. He became a publisher. He began to write books. And look at these books. Oh my gosh. The Isaiah Effect, the God Code, Secrets of the Last Mode of Prayer, etc., etc. These are all New Age pseudoscience texts. Oh dear, something was blinking at me. Anyway, this is all baloney. This is worthless stuff. These are not qualifications to understand what's going on in sciences. Let me do something here. That's better because it was blinking at me. So it's going to be a little darker, but that's all right. So he wrote these garbage books, New Age crap, and that's all his qualifications. And as we've already seen, he's very willing to lie about everything because he doesn't understand anything. What about Peterson, you might be wondering? Surely he must have some really wonderful qualifications to offset this bozo. No, this made me laugh. It was hilarious. If you go to Peterson's Arlington Institute, that's where he's supposedly connected, and you ask him, what's his expertise and his attributes. Look at this list of empty nonsense. So one qualification, he knows how to think about the future. And he claims the Arlington Institute uses sophisticated processes and information technology to scan the horizon for possible big surprise events. Okay, what systems does he use? His next qualification is an expert in identifying possible futures. So he's a soothsayer, I guess. He can see the future. He looks for early indicators of large-scale change. Okay, what are they? How do you look for them? And then he has a unique understanding of the future, which comes from viewing the emerging environment from a high integrated vantage as informed by a sensitivity to potential unusual events. This is a collection of buzzwords. You know, just to quote Elon Musk recently, he looks like a people person. Now, people skills are kind of useful. There's lots of good people person skills. But this is a guy who's got nothing but vague noise to back up his claims about what he can do. And that's shown by what he's saying about climate change. He can't see large-scale changes coming at us because he's lying through his teeth to maintain the status quo. Okay, but this is a climate change denier, and I showed you earlier a creationist who is pulling the same stuff, misleading everybody about what's known. It's just a really common technique that they use. Just be aware of it and do things like look at their qualifications. Peterson and Braden have no qualifications of any value on these kinds of questions. Oh man, it is getting so dark in here. The sun has gone down and my light quit on me. How annoying. Let's see if I can bring it back. If I do this, that's a little better. Let's hope it doesn't start blinking at me again. Okay. So any questions from the gallery here? I see you're recognizing the nonsense that these people are saying. Yeah, calling himself a visionary. Yeah, that ought to be the first disqualification. If you call yourself a visionary, you're full of it. And similarly, futurist, that's another empty term that they're using. Okay, any questions about anything? Because if not, I have one other thing I wanted to bring up that's kind of interesting. So let me fire up something a little different here. I'm going to share something else. Let's see, where is it? I have so many windows open. Too many windows. It's got to be in here somewhere. Oh, there it is. Okay. Yeah, there we go. And now it's obscured. Your comments, I'll bring them back. All right, this was a really interesting story, and several people have pointed this out to me. You may have seen it already. The mouse with two dads. So scientists create eggs from male cells. This is kind of an expected technology. This is not a surprise. This is something we could have anticipated, that this would be coming along eventually one day or another. And here it's occurred. What these scientists did is they took stem cells from male mice. Okay, so we got a male mouse, and you treat it with a number of fancy treatments to sort of get it to regress to a generic stage, and then redevelop into a kind of ovarian cell so you can make an oocyte from it. So this has been going on for a long time. We can also do the reverse, take female cells and develop them into a sperm. Yeah, so it's just basic developmental biology. This particular article does make a point, an important point. It says, the proof of concept mouse experiment will have a long road before use in humans is possible. And this is an important point. It's true. Mice are kind of weird in some ways. They are different from us. And you can't simply translate a technique from mouse to human. It's going to take years of experimentation to replicate it in humans. And it's also going to be difficult to do because research of this kind on human tissue is much more tightly regulated than similar studies in mice. So yes, it's possible, but you'll have to wait a while for it, 10 or 20 years maybe, before we can do this in humans. Okay, there's a couple other points made in this article that are worth bringing up. Look at that survival rate. They did 630 embryos and only 7 made it to pups. And those did grow up and were fertile as adults, so that's a good sign. But that's a really low yield. That's going to be a tricky one to implement, even in mice, and it's going to be even harder in humans. So it's going to take time to do that. Also, they don't talk about it here much, but a current concern I would have, well, they do mention they've got an epigeneticist working on it. One other concern is that the way they are doing this is they're taking a female egg, or no, they're taking the male cell and they're inducing loss of a chromosome. So it's losing the Y chromosome. So you basically got an XO cell type. And then you induce replication of the X chromosome. So you get to the XX state, which is great. It works. They got a few individuals out of this. The catch is that in humans normally, and in mice as well, there's epigenetic modifications of the X chromosome. So, you get one X chromosome from mom and one X chromosome from dad, and they have different epigenetic marks. So some genes are turned off in the male X chromosomes, others are turned off in the Y chromosome, and those complement each other. So it's important for dosage. If you do what they do here, which is just replicate the parental X chromosome, then you have a condition called uniparental disomy. That is, you got 2 identical chromosomes that are modified epigenetically in exactly the same way. And apparently sometimes they will regress and you'll get a normal pattern out of them. But I bet you that's one of the major causes that they have so much mortality, is that they've got essentially a uniparental disomy condition, which isn't so conducive to normal development. When that kind of thing happens in humans, you get syndromes like Angelman syndrome or Prader-Willi syndrome, which cause all kinds of problems for the children that are afflicted with these things. so they haven't overcome that. That's something they'll have to figure out. And if I were trying to, this would be weird. If I were trying to convert one of my cells to an egg cell so I could have it fertilized by my good buddy over there, I would be very concerned about this, that there might be all kinds of side effects of this process. So like I said, we're talking decades until they work out the details, but it's very interesting and is probably going to give a lot of turfs the heebie-jeebies. So that's a plus. That's a good thing. It's just an interesting thing for now that we kind of knew would be possible somehow, and now they're working out the details of exactly how to do that. Okay. We're getting up on that time when I'm going to have to stop because you don't want to hear me rattle on for over an hour. Let me mention one other thing, another request I got from a reader on Patreon. They said I should plug my book, my ancient old book from long, long ago. So I had to look it up. You can still buy my book on Amazon. I don't know how. I know it's out of print, so there's no new copies being printed. But apparently they got a stash of paperbacks and hardcovers that you can order. And of course, the Kindle edition is still around. And that does never have to go away. So yeah, you can get these on there. I'm very flattered to see that it's got 4.5 stars. Oh, look at those ratings. I never look at ratings. So I'm kind of thrilled that I look for the first time and hey, it's doing pretty well as far as that goes. It's not selling a lot right now. Obviously, this is years ago that I published this. I will also mention that the audiobook is a good choice. Yeah, because the audiobook is read by none other than the inimitable Aaron Ra. So if you like Aaron's stuff, he's got a good ferocious voice. It's not a very ferocious book, but okay. He's going to add a little quality to it that's pretty good. So I'll plug that as well. Go ahead, get the audiobook. Part of that money will go to Aaron Ra too. So you're benefiting me and you're benefiting Aaron. So all good to do. What is the book all about? The book is basically a collection of my blog posts from years ago. So you can also get that for free just by reading my blog. Blink, blink, blink. Oh, stop that. Goodbye. We'll turn that off. We'll go dark for a little bit. Yeah, so what's the book about? It's a collection of my essays on this stuff. And it's a little different than you might expect from a militant atheist like myself, because I'm really taking the attitude that it's hilarious what these people believe. I'm still very militantly against religious fundamentalism, and the book is making fun of all that kind of nonsense. So like creationism, biblical literalism, intelligent design, all that stuff. Really, you need to laugh at it, and that's what the book is all about. So yeah, you can go ahead, order that, send me some money. I got a question. Would I do a sequel with more recent blog posts? I don't know. I kind of feel like what I really ought to do is retire and then write all new, fresh stuff. So that's kind of where I'm thinking about going. Is I've got some ideas for a book. I got ideas for a book about spiders, for one thing. Yeah, that'll be real popular, much more popular than an atheist book, right? But it's there. Okay. So Mark got and read the physical book. You liked it. Thank you. Very good. Yeah, I kind of feel like it's not a great book, but it reflects my attitude towards religion. And so in that sense, it's an honest book. That's all I cared about. So it'd be nice to do, yeah, like Platolobium suggests, it'd be nice to do a sequel, but I want to do it a little differently. So yeah, I just have to retire and get the time. Because like I said at the beginning, I have been swamped all of this semester. Too much teaching. So I love teaching, but it doesn't leave much room for anything else. So being able to go off to something else would be kind of nice. Arjun says he read it years ago. Oh, the time of Kitzmiller versus Dover. Yes, Kitzmas. Uh-huh. Yeah, that was, that I'm gonna be an extremist here and say, yeah, that's why intelligent design has died, is basically Kitzmiller versus Dover. The intelligent design proponents don't realize it yet, but they're animating a corpse because it got so thoroughly disemboweled. And it was based on a lot of nonsensical presumptions by the creationists. So yeah, it's the Walking Dead at this point. Oh, gonna go for it. Suggests there was a creationists gave a link to a scientific paper about prayer curing blindness. Would I be interested in doing a video about that? Yeah, I got time this week for a change. I'm actually thinking about doing some one-offs like that. So yeah, I would be willing to do something like that. I'll look into it and see what else there is. Got to find something that grabs me, and then I'll put together a short video about it. Because everything comes crashing down after this next week, and I'm back into it. Okay, it's been an hour. I hate to be too long-winded, so I'm gonna cut it off here. Anybody have any questions, comments they want to make? I'm happy to address them if we can do it real quick. Otherwise, I'll save them for the next time I do this. Got to figure out why my light was blinking. Have to do that too. Okay, I will let you go there. Thanks for stopping by, everyone. It's been fun. I'll do it again. I promise. I threaten I will do it again. And we'll talk to you all later. Good night.